Hello, ladies and gentlemen. Welcome to Tecnicelpa. My name is Joachim Imhof. I'm the Senior Promotion Manager Biosites, and in my session today, I'm going to introduce you Corita's Dealerate CRR system. A perfect biocide system, but also giving you a lot of advantages in the paper production. First of all, a short introduction why Corita developed such a biocide system. Later on, I will explain you what is the Dealerate CRR system, the benefits. I will give you some case studies from applications in the field, and at the end of the session, I'm available for the online Q&A. The introduction. All of us, we know in the production of packaging and board, we have such conditions. Low ORP value means up to -200, -300 millivolt. Low pH values 6.2, 6.3. A high COD load of 15,000 ppm. A high load with VFA, volatile fatty acids, up to 10,000 ppm. A lot of anaerobic conditions means a lot of jests with a long holding time. Also, order is a problem, often that you have these H2S problems inside your paper machine and outside. And of course, also additional problems occur in your wastewater treatment plant. Here especially to mention the anaerobic reactors. Here you can be faced to scaling in the reactor, pellet grow or not pellet grow, better to mention, and also the COD removal. The order problem. Order is a typical problem for packaging and board due to the use of OCC, old corrugated cardboard. No fresh fibers are used. So the raw material itself coming with a low pH and a low ORP to the process itself. And in such conditions, the microalgae is growing extremely good and is producing these volatile fatty acids. So you can see here listed butyric acid, acetic acid, all these kind of acids are produced by the bacteria, and of course this is creating a lot of odor. But why this is produced in such low pH and lower P, especially bacteria in anaerobic conditions producing these acids, and so they feel quite good. So the target of a good biocide treatment is to increase the pH and to increase the ORP. And for this, our oxidizing system, like our Dealerate CRR system, is excellent. Oxidizing system, like the name is saying, have a positive oxidizing potential. This means if you're going, for example, here on the left graph, from the VFA from -400 to a 0 or +100, you can see the amount of the VFA is already reduced. This also you can see in the H2S in the air. You can see also here, if you're increasing the ORP in your system itself, H2S in ppm is also immediately reduced. And of course, increasing pH means also that you're reducing H2S in the vapor phase. So to sum up, if you have a good functional biocide system, you can increase pH, you can increase ORP, and you are going to remove these odor issues. So what is the target for perfect or for good microbiology control system? You should increase your pH above 7. The ORP should also round about 0. You should avoid these anaerobic systems or these anaerobic conditions you have in your system. You should also reduce, let me say, the deposits itself in your paper machine. The question is how to do. For this, Corita is offering the Dealerate CRR system. The Dealerate CRR system is a combination of the well-known Dealerate BCS system, in situ biocide based on monochloramine, and Dealerate B. Dealerate B is a booster additive which is increasing ORP and pH. For this, we are using our adapted and specified equipment. We have a in situ system production of our Dealerate BCS system with a perfect equipment which are remote control and online access from all over the world. Our Dealerate B system is dosed by classical pumps, but it's connected to our BCS system, and we have the sensing BCS. This is our online monitoring tool to control the KPIs, for example ORP, pH, conductivity, but also MCA, the active substance of the biocide system. Going into a little bit deeper in the strengths of the Dealerate CRR system. The CRR system, or BCS system, one part of the CRR system, advantages are big. We have here, it's a complement to the BFR, Nordic Swan Eco-Label, FDA. This system itself is not influencing on corrosion, and also it's working as a very good biofilm remover. And we are not generating any kind of AOX with the Deloitte BCS system. The Deloitte B itself, it's increasing ORP and pH immediately and is also compliant with BFR 36. This is a simple chemical which is easy to dose and is increasing the performance of our MCA system. To summarize, what are the benefits of our system? We have a very good, perfect microbiological control. We are increasing ORP. We are increasing pH with the system, and we avoid any issues of odors with the system if it's used well. Coming now to the case studies. Meanwhile, we have several applications in the field, but with different kind of KPIs. In the first application I'm going to introduce you, the KPI was really easy. The KPI was reducing of COD and calcium load in the inlet of the anaerobic stage, because here the customer were forced to big problems with scaling. You can see this is the inside of an anaerobic reactor. All the inlet was blocked, the pipes were blocked, and you can see such kind of here scale rocks were removed frequently of the anaerobic reactor. Paper machine itself, you can see some data of the paper machine itself. It's producing 135,000 tons per year. And you can see here once again, it's mentioned what was the conditions before we had, like COD, pH, ORP, and calcium value. Dosing points of the Deloitte CRR system was the Deloitte B into the pulper, this means at the start of the paper production, and the Deloitte BCS system, the biocide itself, in different dosing points at the paper machine, starting with machine chest, going up to the white waters. Fresh water itself was treated with an additional oxidizing biocide. So here you can see first of all the trend of the pH. You can see before our start, let's go to the delta purge, which was the outlet to the wastewater treatment. The pH was roughly about 6.3, 6.4. And you can see that we were able to increase the pH by time to above 7. Here these ups and downs, it's related to trials by increasing or adapting the dosing amount to the needs we have to avoid overdosing. In the second graph, you can see what happened with the calcium concentration in the paper machine and of the inlet of the wastewater treatment plant. You can see here mesh chest, for example, in the pink graph. It's going dramatically down from 1,800 roughly about to 800 ppm, and also again in the delta purge in the outlet. Here it's to mention that you need a defined amount of calcium which is going to your anaerobic reactor. That's why you can see this up and down. Because the outlet of an anaerobic reactor, roughly about 150 ppm, should stay in the anaerobic reactor of your calcium. Otherwise, the pellets are not heavy enough and you will lose them in the anaerobic reactor. In the next slide, you can see once again pH, calcium, and the COD. And you can see here also, for example, the COD in the wastewater, where we've been from 16,000 ppm going up to 10,000 ppm. Also here, the COD in this application was really well reduced. So to summarize the first application, you saw that we were able to reduce the COD, you saw that we were able to increase the pH, you saw that we were able to reduce the calcium load. But in addition, you can see, for example, that the working of the anaerobic stage, especially after gas production, was increased by 12%. So this is an additional benefit we achieved in this paper mill. And also, I would like to mention that we were able, or the customer were able, to increase the production roughly about 10%. This was related to a better performance of the strength of the paper. In the next case study, we are speaking about a closed loop. These paper machines are really totally closed. And you can see also here, the target was in this case to increase pH and reduce the other KPIs. Here, for example, in the blue line, you can see the ORP. It was up to -200. After using our CRR system, we increased the ORP roughly about 0. Here the conductivity, I would really like to mention, we started with 14 millisiemens and reduced the conductivity up to 8 millisiemens. The pH itself also in the same amount, we increased from 6.3, 6.5, roughly about 7. Also here, you see, the system itself were able to reduce the COD, the system were able to increase pH and ORP, but also in these applications were able to achieve the dosage of deformer and to achieve a reduction of the retention aid dosage. In the last case study, we are speaking also again the same KPIs like COD removal, but also we are faced to reduce the calcium level and to reduce the starch which is used in the paper machine itself. Here a specialty of this paper machine is that it's only 2 cubic of fresh water is used in the application itself. So here you can see a trend of the pH in the paper machine. You can see, for example, in the seed box, the green point, we started roughly about 6.4 and now we are up more than 7. In all points of the paper machine, from super clear, clear, silo and seed box, we were able to increase the pH approximately one digit. The calcium load as calcium carbonate in the system, we started with approximately about 4000 ppm and we were able to reduce more than 50% the calcium load in the system. We are now at about 1 gram of calcium carbonate in the system itself. Coming to the COD load in this case, in this application we started also with 15,000 ppm of COD. Also here you can see the points again, like seal box, silo, clear, super clear filtered, roughly about 50,000 ppm. Now we are around about 10,000 ppm. So we reduced the COD load also dramatically in this paper machine, which gives the advantage also itself to the wastewater treatment plant there. Because now the customer is able to increase the production. We see that the customer itself was able to increase the production roughly about 15%. We reduced the COD, meanwhile we are more than 10%, but the biggest advantage we achieved in this application was the usage of starch. Due to the fact that the initial strength of the paper was increased, also the SET values were very well and the customer itself were able to reduce the starch up to 7%. To summarize our CRR system, the dealer-rate CRR system from Graciá is increasing pH ORP. It's controlling the microbiology in a perfect way, but also we are deloading the system itself with inorganic like calcium and COD. And at the end, we are increasing the paper machine productivity and the paper machine performance. Thank you very much for listening. And now I'm ready to join Q&A.
Welcome to learn more about Rantec Systems Vacuum Solutions. Warm welcome to everyone. My name is Lari Lampila and I am working as a sales manager in Iberia and South America for more than 20 years in this business. More than 30 years, Rantec has been developing equipment and tools for paper makers to make their everyday life more efficient, profitable and easier. Rantec has several different product lines for different areas at paper machine. In our main product line, you can find the following groups. Run Pro for better runnability and ropeless tail threading. Run Dry for better dewatering at wire and press section and better cleanliness of the machine. Audits and consulting for the whole paper making line and its sub-processes. And finally, our largest product line in which we concentrate today, RunEco dry vacuum system with a high-performance EcoPump turbo blower. Paper machine vacuum systems can be roughly divided in 3 main types: wet system with liquid ring pumps, dry systems with blowers and turbo blowers, and hybrid systems that is combination of these 2. Normally dry system with turbo blowers gives the best efficiency, due to better efficiency and the water-free construction. Today we concentrate dry systems and hybrids. Dry turbo system can be then divided in two: variable speed turbo blower like eco pump turbos and constant speed turbos. Overall efficiency, if compared only figures on the paper, are quite similar. Anyway, due to flexibility and better adaptivity, variable speed turbo blower will be more efficient in the process. We can say that constant speed turbo blower is mechanically controlled as variable speed is digitally controlled due to frequency converter. If we are mixing liquid ring pumps and turbo blowers in the same, we call it hybrid system. This kind of a system can be beneficial practically only in rebuilt installations where investment can be reduced by leaving some of old liquid ring pumps running parallel with turbo blower. Usually, liquid ring pumps are dedicated to the high vacuum positions where liquid ring pumps efficiency is on its best. EcoPump turbo blower is a modern blower with integrated high-speed motor controlled by the frequency converter. With this technology, we can adjust turbo blower rotation speed and vacuum level according to the real process requirements. As a blower, turbo doesn't need any water to work, but it's totally water-free. No need for sealing water or cooling tower. This, for example, eliminates the risk of Legionella bacteria. If EcoPump turbo impellers EcoPump turbo impellers mounted directly on the motor shaft make construction super simple with only two bearings in the whole turbo blower. This, among all the other features, makes it simple and trouble-free to operate. Compact construction plays extremely important role when doing rebuilds. Narrow spaces and build-up pump rooms require highly compacted and flexible constructions. Compact and highly integrated system is not only giving better value for the space, but it will make installation very straightforward. In a new system, small footprint lowers investment by making pump room and its civil works smaller. Turbo package is in ready-to-run condition without separated gearboxes, drives, etc. When building modern system to meet requirements not only up to date but also for years to come, vacuum systems should be integrated as a natural part of the process. This means automated controls, DCS integrated maintenance information, and heat recovery of the turbo blower. All the vacuum controls will be done by automated valves and blower controls from DCS or standalone PLC. This means that operator will just adjust the vacuum level settings according to the process conditions and the system will adjust all its components automatically. Vacuum system is nowadays not on anymore a separate part of the pumping system, but it can be integrated as part of the whole paper machine, and this will increase the total efficiency significantly. When taking out all of the benefits from the vacuum system, it means also the exhaust air heat recovery. This heat is created as a result of a compression in a turbo blower. We can roughly say that if 1 megawatt is taken from the network, half of that, about 500 kilowatts, can be recovered back to the process use. This can be direct use for the drying hood makeup air system or with separated heat exchanger for other usage like a warm water. In some cases, even direct blow under the hood can be highly efficient and low-cost solution. Exhaust air can be fully recovered in a papermaking process for water heating or drying section heating. It provides several different ways to lift vacuum system performance on a whole new level. Electric motors are always air-cooled, and in modern system even that heat is fully recoverable due to closed motor cooling air system. As important as it is to adjust the vacuum system and the vacuum level, equally important is to understand how much vacuum is needed. That's why Rantec has developed EcoFlow dewatering measurement system. With EcoFlow, Papermaker can see online what is going on with the dewatering positions, flat boxes, Kucherl save-all, failed Dewler boxes, press save-alls, etc. EcoFlow is the window into the wet end process. Measure, adjust, master the process. This is the way to the big savings and better process. Let's go through some new machine installations, from small one turbo blower system up to several big machines. So from one sonnet to the full-size opera. Confidential tissue machine in Poland. Two turbo blowers, highly integrated to the paper machine process. Heat recovery system for warm water. Confidential 11-meter brown grade machine, 11 turbo blowers and EcoFlow system. Basically one blower per each vacuum position, very little expansion losses, preliminary savings more than 50% compared to the machine builder specifications. Savings compared to the specification situation of 5,100 kilowatts down to 3,100 kilowatts. Further optimization will bring even more savings. Then a couple of rebuild cases. Full vacuum system rebuilt in Portugal. 9 old liquid ring pumps replaced with 2 turbo blowers. 2 turbo blower system and EcoFlows was done in 2 steps. No need for a long maintenance shutdown, but all of the works could be done during the normal production. Turbo start also was made one by one. Savings 45% in electricity and 100% in water. Tissue machine in France. Full vacuum system rebuilt, made in 2 steps. 4 old liquid ring pumps replaced with 2 turbo blowers plus EcoFlow system. Savings more than 50% in electricity and 100% in water. And one hybrid system in Sweden. 7 old liquid ring pumps, total of 12, was replaced with 1 turbo blower and 3 blowers. Savings more than 45% in electricity and more than 50% in water. Similar hybrid system has been done also in Soporosel PM2 in Figueira da Foz. Full vacuum system rebuilt in Portugal. 12 old liquid ring pumps replaced with 5 turbo blowers. Turbos and EcoFlows was done in several steps. No need for a long main shutdown, but most of the work could be done during the normal production. Turbo start was made one by one. Savings around 50% in electricity and 100% in water. Full vacuum system rebuilt in UK. 2 old constant speed multi-stage blower replaced with 4 turbo blowers. Better flexibility to changing process conditions. Savings around 50% in electricity. No water saving as old system was dry system as well with turbo blowers. Do you know how good is your system? How can we save energy in vacuum system? Contact your local Rantek representative or directly Rantek Systems in Finland. We will do machine audit and benchmarking. We will find the reasons behind the high energy consumption. What we can do to your process is to control vacuum levels by Run Eco vacuum systems, adding dewatering measurements for the forming and press section, optimize press section doctoring and save walls, optimizing felts. With the improvements, you will save energy, improve the runnability and production. Rantek Engineers has audited more than 1,000 paper machines around the world. All machines have been benchmarked according to the tonnage and vacuum system energy usage, grade by grade. Small grey dots are all machines examined and the big green ones are the machines with EcoPump turbo blowers. Our system set the best practice level for the paper machine's vacuum system energy usage, as you can see. And not only in brown grades and tissue, but for all paper grades there are on the market. Know where you are compared to your competitors. After 20 years and more than 700 turbo blowers in our installed base, we have been able to set a new standard for the papermakers' vacuum systems. With our high-performance turbo blowers, we have been able to save our customers direct electrical usage by more than 1,700 gigawatt-hours per year. That is equaling to approximately 86 million euros annual savings. Water has been saved more than 25 million cubic meters per year. Plus all the collateral benefits that are coming from the optimized processes like reduced dry loads, optimized felt lifetime, and performance, etc. Modern vacuum systems have nowadays an important role in controlling the paper machine, not only the wet end, but the whole process. I want to thank you for your time, and also I want to remind you that whenever you are willing to take the next step for the better efficiency in your vacuum systems, we are here to help you. Thank you very much.
Hi, today I want to introduce the results obtained with the products that Certec 20 has specially developed for cationic starch substitution. First of all, I want to introduce what cationic starch is. It is a modified biopolymer from native starch, mostly from corn or potato, that is widely used in papermaking production, to enhance sheet strength and stiffness, due to the ionic interaction that creates between the starch, fibers and fillers are stronger than simple hydrogen bonds. As you can see in the images, cationic starch is formed by reacting native starch with quaternary amino derivatives. On the market there are available different degrees of substitution depending on paper needs. Now I want to introduce the Certec development has carried out during several years to obtain the Drytec Gamma products. They are a range of synthetic polymers with the intention to substitute partial or totally the conventional cationic starch used in the wet end. Here we can distinguish two types of products. Drytec C Gamma, that is a cationic polymer solution specially developed to work as a dry strength agent, and we also have Drytec A Gamma, that is an anionic polymeric solution developed to increase wet strength rosin fixation. It also can work as a dry strength agent, and it also contributes to a better control of the process ionic demand. Now we are going to talk about how it works. Drytec creates hydrogen bonds and ionic interaction with fibers, but confers a stronger fixation and provides an intense internal cohesion between the fibers. It provides faster reaction speed with fiber than cationic starch. This special feature results in a low dosage regarding natural biopolymers currently found on the market. Drytec can be used in all that kind of papers that use cationic starch, or if you have a need to increase dry strength or internal cohesion. Now in this slide I want to introduce the conditions that we had for the long trial that is presented in this oral presentation. We had a Fourdrinier machine with a production of 4 tons per hour of 250 grams per square meter cardboard. Cationic starch, it was from corn, and it was added at a rate of 8 kilograms per ton. The addition point, it was the blending chest. In this case it has a very compact design, so we have to assume that the retention time is almost zero. Regarding the ionic demand, it was very close to the isoelectric point, and we were said that the best machine performance is achieved at minus 70 microequivalents per liter, but it's quite hard for them to achieve this value due to the high dosage of cationic starch and that they are not adding any anionic product on the circuit. In this presentation I want to talk about the results. I have to mention that in a previous short trial we could totally replace 8 kg per ton of cationic starch per 4 kg per ton of Drytec C225. This one was done step by step. In every step it was replaced 2 kg of cationic starch per 1 kg of Drytec. So in the long trial we did this substitution in just one step, as you will see. We also added the Drytec A250 at a rate of 0.5 to 1 kg per ton that could adjust, help us to adjust the ionic demand to minus 60. We also saw a decrease in white water's concentration by 30%. Regarding paper properties, we saw an increase of 5 to 10% in porosity, tablet stiffness, breaking length, and tensile strength, a decrease by 10 to 15% in tear resistance, and COP decrease from 35 to 30 seconds. As I was presenting before, here you will see the graphs with the data evolution along the trial. Regarding tablet stiffness, we see a tendency to increase. The same happens with breaking length, that we have this tendency to increase 5 to 10%, and also it happens with tensile strength. On the other hand, with tear resistance, we can see that there is a 10 to 15 decrease in machine direction, but we don't see any big differences in cross direction. COP value decreased from 35 seconds to 30 seconds. I have to say that this COP test is more likely to the drop test. Lately, in other long trials, we could adjust different parameters of the machine to keep all the paper properties within specifications. In this slide, I want to present the advantages of Drytec Gamma products. They are ready-to-use products, so we don't need any equipment for its preparation. We can reduce the cost of the cationic starch treatment, as 1 kilogram of Drytec can substitute 2 or 3 kilograms of cationic starch. It can be dosed together with cationic starch, as they are totally compatible. It provides more cohesion between fibers compared to other synthetic dry strength. It improves formation compared to other dry strength agents, and it doesn't not contribute to increased COD load in the wastewater treatment plant. Neither is a nutrient source for microorganisms, as it is not starch-based. Regarding the disadvantages, I have to say that cationic starch is an excellent natural polymer, so sometimes it can be difficult to replace 100%. Our experience is that we can replace quite easily 85% of cationic starch, but this 15% left, it can be quite challenging. Depending on the retention aid in use and how critical it is, it can reduce retention. So, this is why in certain types of paper it is necessary to work together with an anionic dry strength agent like Drytec A Gamma. Drytec has not been designed to substitute cationic starch used to emulsify sizing agents. To do this application, we have other synthetic polymer solutions, in the case that you want to completely remove cationic starch from papermaking process. In the near future, we have to take into account that the starches are most abundant and important vegetal polysaccharides from a commercial point of view. As you can see on the left image, it is mostly used for starch sugar, but it is also used in other industries like medicine, modified starch, beer, chemical industry, food, and also papermaking. Regarding the food industry, it needs to be considered that the expected global population is going to increase. It should also be pointed out that the starches are obtained from annual harvested plantation that can be negatively affected by the climate change that we are presently attending. In this scenario, CERTEC 20 has a firm commitment for innovation and development of technology balanced with profits, consumer demands, regulations, and energy and environmental impact. Thank you for your attention.
Okay, thank you very much to the three lecturers. It's always excellent to listen to some of the advantages and innovations that should support our industry to meet present and future challenges. And just to the audience, please do not hesitate to place any further questions to our lecturers. Please, if possible, refer to whom you are addressing these questions. So let me start with some the questions from the audience. First to Lari. Thanks for the presentation. Very good example of energy optimizing. I was wondering about the relation between the investment and OPEX versus the positive impact, energy saving, green label, social. Can you share your thoughts about it? We cannot hear, Lari.
Normal problem, muted microphone.
Okay, thank you.
Okay, yes, please. Can you repeat the question?
Yes, it's if you can share your thoughts about the relation between the investment and OPEX, so the investment basically versus the positive impact, energy savings and some other positive impacts like green label, social impact. So which is the balance? What are your thoughts about it?
Yes. Okay. So normally, when we are looking back to our project, what has been the investment and what is the payback time, we are talking about normally around 2 to 3 years of payback time. There, of course, there are some better ones. We are talking about the 1.5 year, maybe 1 year, but then even longer one. Normally, it's between this from 1 to 4 years. We have just recently started to, for example, calculate carbon dioxide load that what we can reduce in a production. So we don't have a history of that so long that I have unfortunately don't have numbers for it. But then also what we have been learning over the years and especially the last few years is that there are several other benefits, what we are calling collateral benefits. So that, for example, more stable vacuum levels are better, making the quality better, and then taking the heat recovery together with all the other savings, and that can almost double the savings that we can have from the direct electrical savings. I hope this is giving some idea that what kind of a benefits you have.
Just let me add one additional question. I see that you have also been mentioning about the CO2 footprint. Is it something that it is really driving any investments in this area, or not yet really?
I think it's going to be more and more important. Companies are reporting that how much they are reducing their carbon dioxide footprint. So I think that when we are calculating, for example, how many megawatt hours they are saving per year and what it's equal to this footprint, I think it's becoming more and more important.
Okay, thank you very much, Lari. Just to David, are the synthetic agents used bio-based, recyclable, and food contact approved?
I have to say that they are bioproducts, that they have the food contact approval, also as FDA, BFR 36, and other labels, and that they are also recyclable.
Okay. This another question also regarding to these new synthetic polymers. In what to you, David? In what type of papers can we apply Drytech additives? Also, how does it behaves in systems where we have wet strength additives? Two questions in one. So
yeah. Well, we have done several trials in cardboard production, as it was the trial presented, and also in printing and writing, and special papers from grammages, I remember from 80 to 150 grams. So in this case, I would say that in every paper that they are used cationic starch, we can replace it by Drytech products. And on the other hand, regarding the wet strength additives, as far as I know, we didn't have any incompatibility with dry strength. But it is important to adjust cationic demand, as I saw in the presentation, and that's why usually we go with two products, an anionic and a cationic polymer. With this, we can adjust ionic demand so that the wet end system works as it should be.
Okay, thank you very much. Another question for Lari. Thank you for the cases that you presented. Despite this session being focused in paper machines, can you share some insights on pulp machine applications of turbo blowers, energy savings, challenges, benefits? So more on the pulp side.
Yes. Okay. So we have several references also on pulp drying machines. And if we are, for example, thinking about Iberia markets, the closest ones are in Ence, in Graciá. And in basically the system is the same. So it's the same kind of a vacuum system as on a paper machine or on a tissue machine. What is the challenge in pulp drying machine is sometimes the process temperature, which can rise up to maybe 50 Celsius degrees. That can lower a little bit the efficiency, but normally not even that. So it can be used in every position on a pulp drying machines. And we have, of course, the same benefits that we are having on a paper machine. So it's a water-free process, and we are having the savings, power savings, approximately 50%.
Excellent. Just a question to Joachim related to Kurita's Dilurit CAR system. In which situation or in which paper grades would it be mostly recommended, especially versus standard oxidizing biocide systems like MCA alone? In which situations do you think it's most recommendable?
So we developed this, let me say, biocide system, especially for packaging and board machines, in the application where we face to this circumstance that we have really low ORP values, low pH values, and OCC, the old corrugated cardboard, is used as a raw material. So then you must really figure out also the commercial aspect of using MCA alone, which gives you another benefit if you have this additional booster. So in such applications where you have big holding volumes, where you have big water to treat, and you have this really, let me say, negative influence from all these other physical chemical parameters, then it's really advantage to use the CRR system instead of the monochloroamine system alone.
Okay, thank you. Another question to Lari. Is there an increased needed in cooling? Can it be an overload to the existing cooling towers?
Well, we don't actually need any cooling tower, as we are totally a water-free process. So normally when we are replacing the old liquid ring pump system with the turbo blowers, we can close the cooling tower, and that's one extra benefit as well.
Okay.
So there is no extra load for cooling tower.
Very good. Clear. Another question for Joachim. According to your experience, would it be advisable to combine Kurita's Dilurit CAR system in short loop with a second biocide treatment in the pulp preparation area, so to have both systems in place?
Yeah, this is a good question, because we have on one hand, let me say, the more wet part, like the wet end with a lot of, let me say, flows to treat. And on the other hand, in the pulp preparation, we have a lot of pulp stocking inside the tower. So the monochloroamine system is really excellent to treat the wet end of the paper machine alone. In the pulp preparation, or the stock preparation itself, I would really emphasize or recommend to use there the booster system, this Dilurid B, to increase in this place already pH and ORP, and if needed, organic biocide for conversation of this, let me say, stock towers, where you have really this lot of amount of pulps stored for a longer time, because then you see the difference between a monochloramine oxidizing system and the classical organic biocide. So a combination of MCA and organic biocide in such applications is really possible. But at the end of, you must also decide what is the commercial aspect. So how many euro you have to spend to keep the system clean, and which is the KPIs you are following. So the focus is, in our case, of the paper machine itself to produce the paper, to keep the paper machine clean.
Okay, thank you. Question for David. Just comment is, with starch, is normally observed that the improvement of paper characteristics has a certain maximum limit, no matter if higher starch dosages are added. Would you expect or do you have an experience with dry tech to go beyond these strength limits? Could we expect not only to replace the starch, but to improve paper characteristics?
Yeah, well, in this case, as you are saying, the fiber has a limit to fix things such as a starch or a dry tech. So we are not expecting to improve starch characteristics with dry tech C gamma, but maybe we can improve a little bit with the use of dry tech A gamma, as it is anionic. It can create further interactions between starch and fibers. So I would say that with the dry tech C gamma, the cationic gamma, we are not expecting an increase, but yes, with dry tech C, or a combination of three of them.
Okay.
Maybe we can reduce 50% or 60% the incorporation of starch and introduce dry tech C and A gamma.
Just for my own knowledge, is there any property that it is more boosted or more enhanced SCT, or is there something that you would expect more or burst? I don't know. So what could we expect?
Yeah, what we are expecting is to increase internal cohesion, and as far as in the most of the trials, especially in cardboard, also stiffness.
Okay, very good. Just another question for Lari. Energy and water consumption reduction are clear targets in our sector. In which cases would you especially recommend these audits, this evaluation or implementation of such strategy, such eco-pump turbo blowers, which would be the typical case that someone should consider to work or to work in this area?
Yes. Well, first of all, of course, if you are in a situation where your pump lifetime is in the end, so you anyway need to do something for your vacuum system, then if energy price is high, that's of course you can get the direct benefits from there, and then if your system is you are going to rebuild, you are going to make changes for the press section or wire section, you are changing the grade, so you anyway need to do some modification for the vacuum system, then this kind of engineering for the vacuum system can be very, very beneficial. Very typically nowadays, when paper masses, for example, are changed from the other grades to the brown grades, and there are going to be lots of modification anyway for the paper machines. It really makes sense that we are taking the vacuum system as well in the total consideration of the rebuild, and there you can get really nice savings.
Okay, excellent. Okay, a question to Joachim. Despite being widely used, one of the potential dangers of oxidizing biocides like MCA or similar, dosed in short circuit, is corrosion. Actually, you have already mentioned this corrosion issue, especially in vapor phase. Is there anything that you could say related to this on top of what you have mentioned, especially compared to MCA?
Yeah, so first of all, we will start. It's clear oxidizing and corrosion, it's named in the same sentences every time. The question, first of all, is the dosing amount and how much oxidizing biocide you're adding to a system. So if you keep all the time a high level of a 10 or 15 ppm as a residual chlorine, then it's clear you could be faced to a corrosion. But in our application, the specialty of this monochloroamine system is we are producing in situ from an oxidizer and a salt solution the monochloroamine, and we are adjusting the monochloroamine in that way that we are not generating free chlorine. So this means we have a monochloroamine, which itself it's not corrosive, with really low ORP if you compare it to other oxidizers, which have a really much more higher ORP level, means it's activating or active with all the other, let me say, metals, for example. So corrosion with the BCS system, no. And we did a lot of tests also in the field, in the vapor phase drying section, but also in the white water itself or surrounding of the paper machine with different kind of metals to show that we have no corrosion effectivity of our product itself. So at the end, it's really a question of how you adjust the in situ produced biocide and how you can control this in situ production by time with the dosing equipment to avoid, let me see, to generate free chlorine and to have this free excess of the ORP.
I think it's a good comment. Thinking of a long-term potential corrosion issue. So it's thank you for the reply. One question to David regarding dry tech polymers. How dry tech polymers compares to cationic starch in more challenging process conditions such as high conductivity, high anionic trace levels, poor quality fibers. Any comparative experience between the starch and your dry tech polymers?
Yeah, well, in this case, it can be challenging to substitute cationic starch, but we also have to say that as our products is not based on starch, in these circuits that they are very close, to substitute starch with a cationic polymer, we are removing nutrients from the circuit. So this can benefit also the microbiocide activity or the microorganism activity, and at the end it benefits in conductivity or in not in the conductivity but in COD, BOD, and also in the amount of solids sent to the wastewater treatment plant. So I would say that it can difficult to affect to conductivity, but we can affect to other parameters of the circuit that in the overall it can improve paper properties.
Okay. Just another question for you, David, related again. It's looking at fines retention or the improvement of white water's consistency, which is also seen in some other benefits. Have you considered these polymers as a potential component of the retention system? At least it looks to that they have really an effect in this area. So have you think of it as part of the retention system?
Yeah, we have talked about, we had long discussions about this, and of course, if you can, depending on where you add the product, it has a behavior or another. Likely to start. If you add it in mass, you have you potentiate or increase paper properties. Regarding that, if you add it next to the headbox, then you are affecting retention. So depending on each case and where you add the product, you can make to act it as a retention aid and in the line that you were talking, or as a retention as a dry strength to increase paper properties. So it can. It's something that we have discussed about this issue, but as far as I know, we didn't realize at industrial scale yet.
Excellent. One question for Lari. How efficient or flexible are these EcoPump turbo blowers in front of process changing conditions? For example, a relatively sudden change in pulp quality. Are they reacting according to this changing environment just to get the right, let's say, efficiency, the optimal efficiency?
Yes. Well, blower itself as a device is very flexible for the changes of the flow, and this is very often in case of these sudden process changes, like changes in pulp, but also changes in felt condition, the felt age, the wire age, and so on. So we are always dimensioning our system so that there is a certain a window, certain maybe hopefully 20%, up to 20% of extra capacity. So there is a certain window where we can play, and automatically the blower is always adapting into these changing process conditions. So let's say they are very easy for our system.
Excellent, excellent. I think that we are reaching the end of this session. I would like to thank very much to our lecturers and to the very active audience. Really, it's a pleasure to have so many inputs from the audience, even in these difficult conditions. Now it is time, still 2 minutes left. So if there is no additional questions, it is time to give the floor to the next session, which will be moderated by Miguel Zanutini about biorefinery and biotechnology. So again, once more, thank you very much to you three, and thanks Tecnicelpa for arranging this very interesting, really lectures.
Yes.
Thank you and goodbye.
Thank you.
Thank you very much.
Bye.
Thank you. Bye-bye.